Welcome to Physics for Everyone classes. This is your Satish. So in this video, we can see some applications regarding the rotation of the rod and the uniform magnetic field. In the last section, we have seen how much is the induced EMF which is developed across the ends of the rod when it is rotating with a constant angular velocity omega. How much we got as it is b omega L square by 2. By using this result, in this section we can see a few illustrations how to calculate the induced EMF in various cases. Let us start the today topic. Applications. So our first application, initially we need to set a uniform magnetic field in the given region. Let us take a uniform magnetic field in one particular region. The cross indicates the magnetic field is acting into the board or along the negative z-axis. This cross indicates the direction of magnetic field, B bar. In this region, we need to set a conductor. Let us take, this is our conductor, and whose length we can take it as AB, where AB is equal to, suppose I am taking it as 3L. The length of the conductor is taken as 3L. Here I am taking the point of rotation of this rod somewhere else. For example, I am taking the axis of rotation which is at a distance L from the end A. So this is the point where the rod is rotating with constant angular velocity omega. And the point B, which comes the distance from the axis of rotation, which is equal to 2L. Because the total length is taken as 3L, and where the axis of rotation is set at point O, the distance from O to A is taken as L. Therefore, the distance from O to B comes as 2L. And here, we are interested to find what is the potential difference across the ends of the rod, which means B to A. So what we need here, EBA, EMF induced across the entire length of the rod, which is how much? In order to find this one, we are using the result where we know E is equal to B omega into L square divided by 2. This one is applied between the 2 points where the one point is the axis of rotation, the other point is at some distance from the axis, whereas L is the length from axis of rotation to the given point. Now apply this result between the point O to the point B to get the induced EMF across O to B. Now tell me, out of these 2 points O and B, which point will get the higher potential point? As this rod is rotating in clockwise direction, for example, if you take some part of this OB length, it has got a velocity V. To know the position of positive polarity, we are taking the direction of V bar cross B bar. So V bar is in this direction, B bar into the board. So V bar cross B bar, the thumb is going towards the point B. So the point B comes as a higher potential point, whereas point Y is the lower potential point. Now I can take induced EMF across the 2 points B and O which is equal to how much it is with this result? B omega L, the length between the points O to B whole square divided by 2, which is equal to B omega. What is the length between the points O and B, which is taken as 2L? Then it comes as 2L whole square divided by 2. That is equal to 2 square is 4. 4 by 2, it comes as 2. So 2 into B omega L square. So induced EMF across the 2 points B and O is 2 times of B omega L square. Similarly, we need to find the EMF across the points O and A. You can write EAO, which is equal to B omega. The distance between these 2 points, we can write it as LAO whole square divided by 2, which is equal to B omega. What is the distance between the points O and A? It is L. So L square divided by 2. We are interested to find the EMF across the ends of the rod. So how you can write this expression in terms of these 2 expressions? Let us see. So EBA, we can write it as EB minus CO minus of EA minus EO. If you expand this one, here minus EO is there, minus of minus plus EO comes, and these 2 terms will get cancelled. This one and this one will get cancelled, and finally you will get EB minus EA. So what we require that part? So that is equal to EB minus EO, EMF induced across BO. We got the result, which is equal to 2B omega square L square minus EMF across O and A. Here it is there, B omega L square divided by 2. By taking B omega L square common, how much you will get? B omega L square is taken out. 2 minus half means 2 minus 0.5. Then it comes as 1.5 times B omega into L square. So we got the result, EMF induced across the 2 points B and A. The result is 1.5 times of B omega L square. You can see, by comparing these 2 points A and O, the potential at O is lesser than the potential at A. How? As this part is going down with velocity V, the same time the part OA is moving with velocity V in the upward direction, and the direction of V cross B, V is in this direction, B is into the border, and you will get the thumb is acting towards the point A, where you will get the higher potential point. So A is the higher potential point with respect to the axis of rotation of the point O. By comparing these two, B and A, both have got the positive polarities. But out of these two, the one which has a higher magnitude of potential, which is the point B, because EMF is proportional to the square of the length. Where you will get the more length, there you will get the potential difference is also more. So we can relate potential at point B, which is greater than potential at point A is greater than potential at point O. And this part is being assumed like one battery. For example, this is the axis of rotation. From here you can imagine one battery whose EMF is equal to E1. EMF across the points O and B. On the other side, if you take towards the point A. Here it comes as the lower potential point, and towards the A is the higher potential point. This is E2. It is clear that these two cells which are not in series in the sense plus minus, it should go in this manner. You got positive polarity with negative, and negative is followed by again negative and then positive. There, to find the effective EMF, we need to take the difference of these two EMFs, which we got in the answer 1.5 times of B omega L square. So clearly, E1 magnitude is more than E2. To find effective value, the difference you will get U1 minus E2, which is nothing but the answer 1.5 times of B omega. And now the second application here. Let us see the board. Here I am taking the two elements. The one is AB, which is a non-conductor, and BC is in the form of a semicircular conductor. So AB is a non-conductor whose length is L, and BC is in the semicircular arc, and whose length is taken, whose radius is given as R. Length we can take which is equal to pi into R. So length we can take which is equal to pi R. And this entire system is placed in the uniform magnetic field again, which is acting along the negative z-axis. Now, about the point A, the system is rotating in clockwise direction. Here, we are interested to find the potential difference between the points B and C. There you can see what is the EMF which is induced across the points B and C, where we can say for this semicircular ring or a rod, these 2 points are diametrically opposite points. So how much is the potential difference between the points B and C is equal to how much? Now to find this one, again we are using the result, the EMF which is induced across the length of the conductor when it is rotating about an axis is given by E is equal to B omega L square divided by 2. This is our result. So we are using this result to this question. So initially we to find what is the EMF which is induced across the points A and B. How much is the induced EMF? Then we can write E B A. EMF induced across AB, EBA, which is equal to B omega. What is length? S. A to B length L is given. So B omega L square divided by 2 directly. And the EMF which is induced across A to C, there you can take ECA, which is equal to B omega, the length from C to E or A to C. This length we need to find, this one. There you can see the angle between these two lines is 90 degree, and here it comes as right angle triangle, and AC is the hypotenuse of this triangle. So directly you can write the one side length is L, the other side length comes as 2R. So CA distance, or we can write CA square, hypotenuse square is equal to side square L square. The other side is 2R, B to C distance is 2R. 2R whole square, 4 into R square. And then you can write directly the length AC square or CS square divided by 2, which is equal to B omega. What is CS square? This one. L square plus 4 into R square divided by 2. Now, the potential difference across the ends BC, there you can take BC. There you can see clearly, comparing these two, whose EMF is more? the second part. EMF across CA is more than EMF across BA because B omega by 2 is common in both the terms. There you can see B omega by 2, here also B omega by 2. Here the term is L square and the second term here is L square plus 4 into R square. We added something here, which means EMF across CA, which is more than EMF across BA. So, EMF across CB we need to take. So, let us change this as to get the positive result. Write it as EMF across C2B, which is equal to EC minus CB. And this we can manipulate as EC minus EA minus of E, the second one is B minus EA. Once we expand this, EC minus EA minus EB, minus of minus comes as plus EA. EA will be cancelled, you will get the EMF across CB. So we know these two values, ECA, EMF across CA, this much, B omega by 2 into L square plus 4 into R square minus EMF across BA, which we got here as B omega L square divided by 2. So for the given values, how much L is given, how much the radius is given, if you substitute here, you will get the result. And even we can simplify this one to the next level. How much it comes? Let us see. B omega by 2 is common. So EMF across CB is equal to B omega by 2 is taken common. And the first term left is L square plus 4 into R square. In the second term L square. L square get cancelled, which is equal to B omega by 2 into 4 into R square. Here 2 will get cancelled 2 times. And finally I got the result 2 times of B omega into R square. And here is the result for this question. How much? B omega R square into 2. So EMF across the end points for this semicircular conductor ECB is equal to 2B omega into R square. Right? You see, for dealing this kind of questions, the rotation of the conductor or for a given system inside the uniform magnetic field, our general result is across the axis of rotation to the given point. We are taking the result. With the help of this result, we are finding the potential difference across the any two given points inside the given conductor.